This is Dr. Allaire. Thank you for tuning in and watching this video. In this video, which is the first of a series, I will be reviewing questions relating to our quizzes in EED 3315 that focus on the science teaching competencies. Now, just to remind you, the science teaching competencies are different from the TEKS. The TEKS are what we use in the K through 12 classrooms to gauge student success, as it were, in science, as well as the other disciplines. The science teaching competencies is what the state of Texas has determined are the things that teachers need to know in order to be able to teach science. And so the science teaching competencies that we are focusing on in EED 3315 are the competencies that cover early childhood through 6th grade. And so we've set up in this class a series of quizzes to help you, the student, prepare for your certification exam. So in each of these quizzes, each quiz will focus on 2 science teaching competencies. This particular video focuses on competencies 1 and 2. Those are the competencies that we will be covering in this particular video, and that are covered in the 5 multiple choice questions that were contained in quiz number 1. And so what I'm going to do now is I'm going to share my screen, and we'll take a look at these. Take a look at the questions in quiz number 1. Again, quiz number 1 focuses on competencies 1 and 2. Now, one of the things, just to point out here, just a housekeeping item, as it were, that what you see on your screen as far as the look of things is a little bit different from what you saw on the screen when you took your quiz. And that's because this semester, I am administering the quizzes through Canvas. However, what you're looking at is the quiz on a different program called Socrative. Socrative is a great program. It is, for all intents and purposes, a free program, although there are some extra bells and whistles that you can get if you pay for it. But it's a great way of doing quizzes and different kinds of assessments in an online environment. And so I'm using Socrative here because it gives us a nice space to look at the question and to for me to explain things. So let's go ahead and jump right into it. Question number 1 says, Mr. Garcia is measuring the mass of an object he knows to be 250 grams. He sets it on a digital balance and it reads 250.02 grams. A second measurement on the same balance reads 249.98 grams, and a third measurement on the same balance reads 250.01 grams. Which of the following statements best describes his digital balance? And so we have 4 statements here, A, B, C, and D. A says the balance is accurate but not precise. B says the balance is both accurate and precise. C says the balance is neither accurate nor precise, and D says the balance is precise but not accurate. And so you need to determine which of these statements is the most correct statement. And so what this question really gets into is this idea of accuracy versus precision. Now, these are 2 terms that often go together, and a lot of people confuse them. A lot of people think that they mean the same thing, but actually they are different. And so what I'd like to do is start out by really kind of giving a definition of both accuracy and precision. So accuracy has to do with how close a measurement is to a stated or accepted value or goal. Okay, and so that's why it's very important in this case for us to know that the value of the object that Mr. Garcia is measuring, he knows it to be 250 grams. That becomes a really, really important part of this problem. Okay, and because since we know how much that measurement is. We know that this object has a mass of 250 grams. That allows us to compare the values that he got to the one that is stated or accepted. So even though we're not right on 250 for each of the three measurements, we can see that each of the three measurements is very, very close to that stated or accepted value. And certainly for an elementary classroom, this would be very, very acceptable. For something like an engineering lab, this would not be acceptable. Okay, they would not be considered accurate measurements. But for an elementary classroom, these would definitely be considered accurate, because 250.02, 249.98, and 250.01 taken by themselves, all of those measurements are pretty darn close to that stated or accepted value of 250 grams. Now, how is that different from precision? Okay, precision has to do with repeatability of a measurement. Are we so a good way of putting this would be something like again, repeatability of a measurement. Do we get the same or similar measurements consistently? Okay, that's probably a good way of putting precision. And so it's not just about measuring something once and you're one and done. We did 3 measurements just to make sure. We always measure things multiple times in science. And as you can see, even though we didn't get the exact same thing each time, we are really, really, really close to that 250 grams overall. 250.02, 249.98, 250.01 are all really close to 250, whether you take them on their own or you take them together. So that means that this balance is both accurate and precise. This would be the correct answer for number 1. Now, before we move on, I want to give you a couple of examples here, because we have some statements like the balance is accurate but not precise. The balance is neither accurate nor precise. The balance is precise but not accurate. So I'd really like to show you what these look like in terms of measurements, kind of comparing what these would look like to what it says in the problem. So for instance, for answer A, okay, what would this look like? What would the values look like if the balance was accurate but not precise? Okay, well, this would be, you know, again, accuracy is about how close a measurement is to a stated or accepted value. Okay, so let's say we measured it but we only measured it once. And so what we have is the fact that it's 250.01. We didn't measure it multiple times. We got that. We're one and done. So, you know, we can say that, okay, this balance is accurate, but we don't necessarily know whether it's precise or not, because we didn't repeat this measurement. Because remember, precision has to do with repeatability. If we're looking at answer C, the balance is neither accurate nor precise. That would mean that the values are all over the place. So maybe we measure it and we get 149.99 grams, we get 345.12 grams, and we get 252.75 grams. So not only are these values not anywhere close to that 250 grams, they're not accurate by any way, shape, or form, but they're not precise because these values aren't repeated over and over again. We're all over the place with these values. Finally, with answer D, the balance is precise but not accurate. This might be something like, again, we measure it and it says 145.99, we get 145.98, and we get 146.01 grams. Okay, so this is not accurate. This balance would not be accurate because those values are not anywhere near the known mass of the object that Mr. Garcia is measuring. However, they are all close together. So this balance would not be accurate, but it would be considered precise because all of those values are very close to each other. If you want to think about this in a sports context, let's say you go bowling, and every time you roll the ball down the lane, it goes in the gutter. Now, obviously, that's not what you want to happen. So that means that you're not accurate. But if every single time you roll the ball, it goes into the gutter, you are precise because you are repeating things over and over and over again. Now, it does mean that you're terrible at bowling, but it does mean it also means that you're precise while not being accurate. So I'm going to clear that, and let's go on to question number 2. Question number 2 says, which of the following rules apply to the use of hot plates and burners in the science class or lab? Rule number 1, tying back long hair. Rule number 2, remove or tuck in any loose hanging jewelry. Rule number 3, keep work areas as clear of paper and other flammable materials as possible. Number 4, reach around, not over burners or hot plates. And so the correct answer for this one is going to be the letter D. Okay, because all of these are very important rules to think about in terms of the safe use of hot plates and burners in your class. Now, obviously, when you're using hot plates or burners is going to be determined by the grade level. You're likely not using hot plates or burners with a kindergarten class or a first grade class. Whereas with a 5th grade or a 6th grade class, they would be perfectly acceptable to use hot plates and burners. Nonetheless, I still think that these are important things to talk about because even if you're not using hot plates or burners in your class, odds are you'll have students in kindergarten, 1st grade, 2nd grade, and so on that might be helping in the kitchen at home. And so knowing how to be safe around the stove or a grill or anything like that is very, very important. So you should reiterate to your students and let them know that if they are around a heat source, whether it's a stove, a burner, a candle, a hot plate, that some things that they want to think about and be careful about is number 1, again, tying back long hair. Okay, burnt hair smells gross. And a lot of the chemicals that people use in their hair for styling purposes are very, very flammable. So we definitely want to tie back long hair. We want to remove or tuck in any loose hanging jewelry. So any bangles or watches that might be hanging on somebody's wrists, any necklaces that people might be wearing, you tuck those into your shirt or you remove them while you're working with hot plates or Bunsen burners, because we don't want those to get caught on anything. We don't want them to touch anything because that could, of course, melt things, but then also burn people and cause accidents. We want to keep our work area clean of paper and other flammable materials. We never want accidents to happen, but we always want to prepare for the worst. And if you have papers and things that are all over your desk as you're working with a burner or a hot plate, that's just inviting an accident. So you want to try to keep your work area as neat and clean as possible. And lastly, you always want to reach around, not over top of something, because if you reach over top of something, you increase the risk of, first of all, touching something and causing a burn, or knocking something over and spilling something. And so even if it's just water, you're spilling hot, maybe boiling water, and that can cause a lot of injuries and problems. So we do always want to be careful, and that's why, again, the correct answer for number 2 is going to be D, all of the above. Number 3, which of the following senses is generally not used for making observations in science class? And so out of all of these, the sense that is the least likely to be used is going to be taste. Unless we get very specific instructions from our teachers, we do not want to eat, drink, or chew on anything that we are using in a science lab. We want to use our eyes. So we want to look at things when we're making observations. We want to use our nose. We want to smell things when we're making observations. Do you detect an odor when you're doing an experiment? Is it sweet? Is it sour? Is it smoky? What are you smelling from something that you might be working with? In a lot of cases, and of course we do need to be careful with this, we might want to touch something. We might want to see if it gets hot, see if it gets cold. We may also want to be listening. Listening is a very powerful sense. So we want to be listening to, first of all, to directions from our teachers, but we also want to be listening in case we hear a snap, crackle, or a pop as we're working with something in a lab. But very, very rarely do we want to taste something. We don't want to put things into our mouths. Now, that's not to say that you can't use food for experiments. Food is great for experiments. You just need to be very careful about it, and you need to make your directions very clear to students when it's okay to eat something or drink something that you're using in the lab. Question number 4. This is a great book. If you haven't read it, please check it out. City Green by Deanne DeSalvo Ryan. I hate to spoil the ending for you, but essentially the book is about a little girl who takes it upon herself to transform an abandoned lot in her neighborhood into a community garden. And it's a wonderful and inspiring book. And so this problem says, after reading City Green, Mrs. Thompson gave each student a lima bean plant to measure its growth every day over a 2-week period. Which type of graph would be best to display the data each student collects about their plant? And so the answer here, the best answer here, folks, is going to be a line graph. All right. And in order to understand why a line graph would be the best one to use, we need to talk a little bit about different types of graphs. Okay, so since the correct answer is a line graph, let's start with that one. A line graph is, so first of all, a graph is just a visual way of displaying data. Okay, rather than just looking at something in a spreadsheet, it's a very visual way, a more visual way of displaying data. For a lot of students, a lot of people, we are visual creatures. We have these beautiful eyes in the front of our faces that allows us to learn about the world around us by looking and seeing things. So we are very visual. That's why graphs are really nice. But different types of graphs display different types of data in different ways. So a line graph shows a change over a period of time. Okay, that is the specific reason and use for a line graph. So whether you are monitoring your weight using an app like MyFitnessPal, or if you are going on to your app on your phone, looking at your bank account going up and down, if it's anything like mine, it goes up and then it goes down and way down. And so you can look at that over that change over a period of time and it's going to be displayed as a line graph. Now, how is this different from a bar graph? Okay, a bar graph is used to compare data to each other. Okay, so what we're doing is we're really just comparing raw numbers. So again, a line graph would be the best here because we are measuring that the growth of the plant over a 2-week period. So hopefully we're seeing that graph go up. Now, if we wanted to compare at the end of those 2 weeks, the height of the different plants, you know, how many students' plants are 4 inches, 5 inches, 6 inches, 7 inches tall, then we would use a bar graph. We would collect all of the data together. We would look at the heights of the students' plants, and we would simply say, okay, this many students had a plant that's 4 inches tall. This many students had a plant that's 5 inches tall, and so on and so on. That data would be best displayed by a bar graph. Now, a circle or a pie graph, because those are two different ways of saying the same thing, shows a percentage. All right, and there's our percent sign. And for those of you that don't remember how to calculate a percentage is calculated by taking the part divided by the whole times 100. Okay, and actually what I'll do is I will put this into parentheses, because first we do the division and then we do the multiplication in this case. So we take the part of something, divide it by the whole, times 100. So, if I was looking to see, for instance, how many students, what's the percentage of students that got A's, B's, C's, D's, or F's on a particular test or a project, or at the end of a grading period or semester, I could use a circle or a pie graph to do the percentage. You'll see this in a lot of cases, especially when you're looking at demographics, for instance, of a school or a district or something like that. So for instance, if you want to look at the ethnic breakdown of a district like Aldine or HISD, you would likely see it as a circle or a pie graph showing you the percentage of students who are Caucasian, who are Black or African American, who are Hispanic, who are Asian, and Asian usually gets all lumped in together, even though there are, they could be Chinese, Filipino, they could be Indian, and so on. So that would likely, again, be displayed as a circle or a pie graph, because it's showing the percentage or the part as compared to the whole. What percentage of students are non-white Hispanic students compared to all of the students within Klein ISD, for instance? That would be shown as a circle or a pie graph. Last but not least, in this first quiz covering competencies 1 and 2, which of the following is generally not considered an experimental error? Now, experimental error is sort of a big umbrella term, but there are some things that count as experimental error, and there are some things that don't count as experimental error. And the correct answer for number 5 is going to be A, that goofs or accidents in the lab count as experimental error. So if you are carrying something from one place to another, maybe you measured a powder or a liquid in one part of the classroom, and you're carrying it to another part of the classroom, and you trip, you bump, some of it spills. You are transferring things from one container to another, and not all of it gets into the container. You somehow have an accident or a goof. That would count as experimental error. Now, uncertainty in measurements does not count as experimental error. Okay, so that would be things like you're measuring something, but you're not quite sure. For instance, going back to question number 1, accuracy and precision. If that balance is not accurate or precise, that creates uncertainty in the measurement that you're trying to make. And that uncertainty in your measurement does not count as experimental error. Now, things are, something that is nice and flat and square, like this coaster that I have here, is really easy to measure. You can measure the length, the height, the width of it, because it's flat and it's square, and it's super easy to do that. However, if you have a flat ruler and you need to measure, for instance, the circumference of a bottle, that's a lot harder to do, again, with a flat ruler. So the difficulty in measuring things is that can create some problems during an experiment or an activity. It can lead to some uncertainty in the measurements because you're kind of guesstimating there. But again, that does not count as an experimental error. Now, false assumptions kind of gets into the notion of I kind of liken it to some of a common thing that students do, and that's with rounding. So for instance, if you have a number like 145.98, okay, you weigh something and you have, again, it's a value of 145.98. In a lot of cases, what students are going to be very tempted to do is to write down 146. They're simply rounding up. And that might not seem like a really big deal, okay? But at the same time, maybe they take a measurement that's like 146.15 grams, and instead of writing in 146.15 grams, they instead round down. So we have two completely different measurements, but somehow they've ended up being equal because of rounding. And so this takes us back to that uncertainty in measurements. And while that can create problems in a lab or an activity, it's not considered to be experimental error, okay? And so for that reason, we always want to, going back again to question number 1 in our quiz today, we always want to be as accurate as possible. So if we're measuring something, the length, the width, the mass, the volume, we always want to record as much of the value as possible. And for our purposes at the elementary level, 2 places after the decimal is probably going to be as accurate as you need to be. Okay, so if you get a value of 145.98, that's what you write down, or 146.15. There is that temptation to round. Let's try to avoid that temptation and write down the actual number that we got. And so that's going to do it for our first quiz. Again, this quiz covered competencies 1 and 2. The first competencies, the first 2 science teaching competencies. And so in the next video, the next quiz will focus on competencies 3 and 4. And and of course, if you have any questions about these particular competencies, please don't hesitate to email me, message me, or of course, bring your questions to class and we can make some class time to talk about these particular competencies. But until then, thanks for watching and I'll see you in class.